Hey guys. So I have a request, or I had a request for some 13.4 problems that were given some trouble. I thought that I would do them in class. That way, if anybody else was having trouble with them also, it might help out everybody involved. So let me get those pulled up. So 13.4, remember this was we were still integrating and we were looking at the definite integrals. So where these integrals had bounds. So we're going to look at those. Okay, so first question that I'm going to work with is coming at you in a second. Okay, so you should see my notes there. 5x squared minus 4x plus 7, 0 to 2. All right, so we are going to integrate from 0 to 2 of 5x squared minus 4x plus 7 dx. So in our definite integrals, remember the first step you want to do is just integrate normally. So using the basic rules of integration, we will find the antiderivative of each of these terms. So remember the power rule for antiderivatives. We're going to be looking at that 2 as our n. So our n plus 1 would equal 3 on this first term. That 5 being a coefficient is going to come along. Then we're going to do 1 over n plus 1, x to the n plus 1. So that'll be our first term. And we'll clean that up here in a second. Minus, this is for 4x to the first. So if n is 1, the n plus 1 in this case is going to be 2. So the 4 comes down. We get 1 over n plus 1, x to the n plus 1. And then remember with the constant, when you integrate or take the antiderivative, it just gets an x. Now, instead of having a plus c, remember on these, you're going to take this and evaluate it at 0 and also at 2. So let me clean it up a little bit first. So we'll have 5/3 x cubed minus, let's see, 4 times 1/2, that's just 2x squared plus 7x. Taking that from 0 to 2. Remember to take it at 2 first. So we have 5/3 times 2 cubed minus 2 times 2 squared plus 7 times 2. That'll be your first value. And then you're going to have the subtraction there. And then this term here that you're going to subtract is going to be this whole term with x equals 0. So 5/3 times 0 cubed minus 2 times 0 squared plus 7 times 0. Okay, so before we work the one with the 2's, you guys notice that these zeros in for all of these x's is going to make this whole term equal 0. So we'll just have a minus 0 here. So basically your answer is just going to be whatever you get here. So this is 5/3 times 8. Here we have 2 times 4, and then we'll have plus 14. We don't necessarily need the brackets anymore, but it's a habit. So you guys, this is 8 over 1, right? So 8 times 5 is 40 over 3 minus 8 plus 14. And then we have that minus 0, so I'm just going to leave that part off. Now, the easiest thing to do, we do have a fraction here. The first thing I would do was the minus 8 and the plus 14. Since those are just whole numbers, you can go ahead and call that plus 6. And then you have to add these two fractions together. So when you're adding fractions, so we have the 40 over 3, and then we have a 6 over 1. And remember, you have to get a common denominator. So you're going to take that 6 over 1 and rewrite it as a fraction with 3 on the bottom. So you guys, on the bottom, to get from 1 to 3, you had to multiply by 3. So we have to do that very same on top. And we can call this 18 over 3. So I have the 40 thirds, and then I'm going to write the 6 as plus 18 thirds, and I'm just going to add those together and get 58 thirds. And you should be able to write your answer in exactly like that as a fraction. Now let's look at another question. Not that one. Hold on, let me find the other one. Where did it go? I had these all pulled up. Let me find it. This one, it had negative exponents. Yeah, here we go. So you guys, the next question that we're gonna go through together is going to be integrating from 1 to 6. So integrate from 1 to 6 of the following. Okay, yeah, it was totally muted. I guess that was a thing that Zoom wanted to do also. It just wanted to shut me up apparently. All right, so let me get back. So guys, so I lost you for a second there. I'm not sure why. Zoom went out, came back in. And it was right after we finished this problem here. So I've got the next problem, the second one I want to look at. We're integrating from 1 to 6 of this function here. So the first thing we want to do is look at the 7 into the negative 1. And what I was saying when you could not hear me is that when your power is negative 1, the power rule for antiderivatives does not work because n plus 1 is 0 and you can't do the 1 over 0. So we know that this integrates as a natural log. So the 7 comes down as a coefficient. So when you see that n to the negative 1, think about it as 1 over n, and it might be a little bit more clear why that when we take the antiderivative, it's the natural log. But we end up with the 7 times the natural log of the absolute value of n. Remember, when you're integrating and we put in that natural log, we have to put the argument in absolute values. And this n to the negative 4, we can absolutely just use the power rule here. So if your power is negative 4, think about your n plus 1 being negative 3. So you're going to have 1 over negative 3x to the negative 3. And we're going to take this from 1 to 6. All right, so let's put a 6 in where there's n's, and that'll be your first term. So we'll have 7 times the natural log of the absolute value of 6. Let's call this minus 1/3 times 6 to the negative 3. Sorry. And then over here, we'll put a 1 in for everything. So we'll have 7 times the natural log of the absolute value of 1 minus 1/3 times 1 to the negative 3. So the one with the ones is going to turn out pretty easy. You guys, the absolute value of 6 is just 6. So once you know you have a positive value in there, you can drop the absolute values and just say that this is 7 natural log 6. Now, to deal with 6 to the negative 3, just remember that you're going to do 6 cubed, and then it's going to come down to the bottom. So this is really going to be minus 1 over 3 times, let's see, whatever 6 cubed is. 256, possibly. I'm going to confirm that because I don't trust myself. 216. See, it was a good thing I didn't. So we have this here. Minus, you guys, I mentioned it when we were doing this last time, but the natural log of 1 is 0. And again, with the absolute values, we can drop them because 1 is already positive. But you guys, the log, any kind of log, you take the log of 1, natural log, regular log, base 10, whatever the base is, it doesn't matter. The log of 1 is always 0. So it's definitely applies for natural logs also. So you guys, if this whole term is just 0, then that means this whole term is just gone. And you guys, the 1 taken to the negative 3 power is still just 1. 1 taken to any power is 1. So we just end up with minus 1/3 here. So let's see what we have left. We have 7 natural log 6 minus 1 over whatever 216 times 3 is, 648. And then you guys, this minus makes this a plus 1/3. So on this problem, let me reference it again to see if they specify how your answer needs to be. It says to round to 4 decimal places. So at this point, now you could absolutely put these two fractions together first, or you could stick all of this into your calculator as is. That's totally up to you. Let's see. Yeah, I think I'm just going to do it like this. You guys, just being careful. I'm going to do 7 times the natural log of 6 and get that answer. I'm going to subtract and make sure it's in parentheses 1 over 648. Now I have that answer. Now I'm going to add, and then in parentheses, I'm going to add 1 over 3. So you guys, what I get here, and it said round to 4 decimal places, is I get 12.8741 on that one. So hopefully that helps make more sense of those problems if you were having trouble. And now let's go ahead and start in on our next section. So you guys, the section we're looking at today is 14.2. And we're going to talk about what are called partial derivatives. So remember in 14.1, we started looking at functions that were multivariate. So they had more than one input variable. So instead of just f of x, we have f of xy. Let's see. Sorry, I was trying to find my example, but I couldn't, so I'm just probably going to make one up. So from last time, you should be familiar with functions that look like this. Let's say I've got f of xy equals 3x squared plus 2y squared minus 4xy plus 5x minus 7y plus 9. So it's very long, yes. But we find out that when you have two input variables, sometimes these are pretty long. And that's okay, because we work with each term one at a time. But you guys, what if I asked you to take the derivative of this function? And you might wonder, well, how can I do that? Should I just take the derivative as normal since they're all input variables? Should I just get like 6x plus 4y minus, and then you might get stuck and be like, oh, well, what do I do with that? Well, you guys, here's the problem. X and Y are both inputs. So when you take a derivative, remember how we always have a with respect to? When we only had X as an input, for example, we found dy dx. And what this says is the derivative of the output with respect to the input. When we did implicit, remember every time we had a y and we ended up taking the derivative, we had to add a dy dx onto it because everything was with respect to x. The reason that had to happen was because y was an output. But you guys, now y is an input just like x is. So it should have the same rules apply to it that x does. The problem is we can't actually take the derivative with respect to both input variables at the same time. So instead of being able to do that, we take what are called partial derivatives. A lot of times I'll just say partial or partials. I can take the derivative of this function f. So now I could say dz up here because usually I call z my output here, but I'm just going to use f. So the function f, I want to take the derivative of it with respect to x, or I can take it with respect to y, but not both at the same time. And notice that these little d's look weird. This is a special symbol for partial derivatives. Notice that this little d is not the same as the normal d that we see in dy dx because this is a partial. It's like part of a whole. So we have a different symbol for it. And it's real easy to make. It's like a D, but you do it in one stroke and it kind of leans off to the side. But anyway, so when we see that, I know it's a partial derivative. So I have to choose what I'm taking respect to. Let's choose to take the derivative of this function with respect to x first. So like I said, I can't have a derivative with respect to both input variables at the same time. So I am considering only that x is a variable, which means the way I'm going to take this is that I am going to assume or hold y constant. It's like looking at a function and saying, okay, this function is changing in relation to both x and y, but I just want to see how it changes in relation to x, assuming that I hold y still. So I'm holding y still, and I'm looking at the change with respect to x. This is what I'm going to do here. So if I need to assume or hold y as a constant, that is exactly how I'm going to treat it when I find the partial with respect to x. So with respect to x, this is a constant. Constant, it might as well just be a 2 or any other number, you guys. And it takes some practice to see that y and treat it as just a constant number, but we get better at it as we go. So let's do this one term at a time. So the 3x squared, there's no y's in that at all. That's purely an x term. That's going to just turn out normal, you guys. The derivative with respect to x of 3x squared is 6x. But what about this term, 2y squared? If I'm assuming that y is just a constant number, then y squared is also a constant number. And I'm multiplying it by this 2, which is also a constant number. You guys, this whole term is constant. When I take the derivative of a constant, it goes away. Now look at this term that has both x and y. So think about, remember, y is a constant. So just like this 4 is just a constant number sticking with x, so it's just a coefficient, y is also just a coefficient of x right now. Now, if you just had the 4x and you took the derivative, you would just get 4. The x would just disappear and all the coefficients on x would stay. Well, because 4 and y are both coefficients of x in this case, they stay. So the derivative of 4xy is just 4y. Now, the derivative of 5x is 5. That makes sense. But you guys, this 7 times y is a constant, so 7y is also a constant. So that's going to go away. And of course, the 9, which is actually just a constant, also goes away. So you guys, I end up with the partial with respect to x is 6x minus 4y plus 5. Let's go the other direction. Let's take the partial with respect to y. So this time I have to hold x constant. So with respect to y, what happens to this first term? Well, it doesn't have any y's in it, which in my eyes right now, it means it's a constant number. So it disappears. But the 2y squared, it just has y's in it. So that's just going to be 4y. Now let's talk about the 4xy term. Well, this time y is just to the first power, and that's our variable. So any coefficient that comes with it is going to come down, right? X being one of those. So I'm just going to get minus 4x. The plus 5x is a constant because it doesn't have any y's in that term. The minus 7y is going to become minus 7, and then the 9 still a constant. So cleaning this up, I end up with 4y minus 4x minus 7. So it's a lot to think about. One thing I want to make sure that you're clear on, because the last time we looked at functions or even just equations that had x's and y's in them, we did implicit. And every time we had a y, it got a dy dx. That is not the case here. You guys, nothing gets dy dx or dx dy or anything like that because we're just holding the other variable constant. All right, so let's do another one. Practice. Well, I'd like to say practice makes perfect. Practice makes better. So f of xy, let's say that this equals 3x cubed y squared minus 4x squared y plus 9x y to the fourth minus, I don't know, 10y plus 3x, and that'll be enough. I could go on for days, guys. It's all good practice. Let's take the derivative of this function with respect to x. All right, so with respect to x, if y is just a number, it's no different than this 3. And it's going to end up coming down. You guys, because the x has a cubed on it, you know that 3 is going to come down with the coefficients also. So you guys, you're going to have this 3 because it's a coefficient. You're going to have this y squared because it's coefficient. You're going to have the 3 that came down in front from the power rule. And then you're going to take one power away and get x squared. Doesn't it feel nice to be taking derivatives again? I think it does. I think they're way better. But you guys, I'll clean that up here in a minute. Let's look at our next term. So the y is a constant, the 4 is a constant. The 2 is going to come down in front, so I'm going to have a 4 here. I'm going to have a 2 down in front. The x, I'm going to take a power away, and the y comes down because it's also just a coefficient. Next, you guys, y is a constant, so y to the fourth is also a constant. So this x is just to the first, and I know when I take a derivative, and it's just x to the first, the only thing that comes down is the coefficients on x. So that's going to be 9y to the fourth. The minus 10y is going to go away totally, and then I'll have plus 3. So you guys, one thing that can be tough is like you see this fourth power here, and you just, it's habit, right? You see a variable raised to a power, you want to do the power rule, you want to bring the 4 in front, but you guys, we can't touch that one because when y is being held constant, this is, the whole thing is a constant. So just leave it be unless we're taking it with respect to that particular variable. So you guys, I would clean this up probably a little bit, do the 3 times 3 and get 9. And then I would write it as x squared, y squared. Minus 8xy plus 9, y to the fourth plus 3. Let's take with respect to y. Ooh, and before I move on, alternate notation. You guys, we have an alternate notation for this. So we have this partial notation. Another way to write this, and you might like it better, is like this. So you just write the f with a little x by it, and then that also means the partial with respect to x, which in that pattern, you guys, with respect to y, you could write fy like this. Almost forgot to mention that, but you are going to see that probably in some of your homework questions. So interchangeable. So let's take with respect to y then. So back to the top. On the first term, you guys, this time 3, of course, is a constant, but x cubed is also. So you guys, this is all just a coefficient of y squared. What am I going to do with the 2? I'm going to also bring it down and take 1 away. So you guys, I'm going to have the 3x cubed coming down as coefficient. I'm going to have the 2 that comes down in front and then take 1 away and just get y to the first. Minus, remember, this whole thing, 4x squared, is now just a coefficient of y. And because it's y to the first, all that comes down is that coefficient. Now I finally get to deal with this fourth on the y, because y is not a constant anymore. But you guys, the plus 9x, that is a coefficient. So it comes along. I bring the 4 down in front also and take 1 away and get 4y cubed. The minus 10y becomes minus 10, and the plus 3x goes away. So I end up with 6x cubed y minus 4x squared plus 36xy cubed minus 10. All right. So let's move on to some other types of functions. So these have all just been polynomial, right? You just have variables raised to powers. We get to use the power rule all day long, and that makes us happy, but we have to do some other things too. So you guys, what if I've got exponential terms? So you guys, let's say I have f of xy equals e to the x plus e to the y plus e to the xy. Let's do this in the most basic way first. All right, so I know the exponential rules are a bit different. So if I want fx, or partial of f with respect to x, well, e to the x, with respect to x, you take the derivative, don't you just get e to the x? So that's easy. But you guys, sometimes when you see e, it makes you think variable because it's a letter, right? But remember, e is a constant value. It's always 2.71828 ... So e is just a constant. If y is also just a constant right now, this whole thing, e to the y, that's just going to go away. Now, this one, let's talk about e to the xy. Holding y, acting like it's just another constant number, this e to the xy, you're going to work it the same way you would if you had, for example, e to the 5x. Notice x is our variable. If you had this 5 here, you'd say, oh, 5 is a coefficient on x. You guys, that is exactly what's happening with this y. How do I take the derivative of e to the 5x? Well, I bring the e to the 5x down as is, and remember this coefficient that's on x actually comes in front, and I get 5e to the 5x. What do you think is going to happen with this y? Well, I'm going to end up with the e to the xy, but the coefficient on x, which this time happens to be a y, is going to come down in front. So you guys, I'm going to end up with y e to the xy. So I get e to the x plus y e to the xy. Let's look at fy, or the partial with respect to y. and see what happens this time. So you guys, if I'm going with respect to y, then the e to the x term is just constant. It goes away. E to the y is going to come down as e to the y. And then what's going to happen to e to the xy now? This time y is the variable, x is the coefficient on y, so it's going to be the one that comes in front. And I'm going to get x e to the xy. So I get e to the y plus x e to the xy. So it's all about being careful. When it comes to exponentials, you know that whatever the exponential term is, if it's got a variable in it, it comes down as is. It's the chain rule part. It's the part where you have to take the derivative of this and stick it on that changes depending on what you're taking respect to. Let's look at a natural log problem. You guys, I just want to do f of xy equals the natural log of x squared plus 2y. So what is the rule for natural log? I take the natural log of this. When I want the derivative, it's going to be 1 over that thing. With some chain rule involved. Let's do with respect to x first. So you guys, either way, you end up with 1 over x squared plus 2y. But the change or the difference between these two partials is going to come in the chain rule. Because don't I then multiply by the derivative of this here? When I'm going with respect to x, I need to find the derivative of x squared plus 2y. But if I'm treating y as if it's a constant right now, then 2y is a constant. It's going to go away. And the only part of the derivative I'm going to have is the 2x, the derivative of x squared. So what I end up with is 2x over x squared plus 2y. I think one important thing on these natural log and exponentials is when I look at this, I'm like, oh, I'm treating y as a constant, so it's just going to go away. Well, it goes away in the chain rule part, but remember, whatever is here always comes down as is. Just the same with the e to the xy. It comes down as is, and then I do things around it with the chain rule. So just because y is a constant in this particular scenario doesn't mean that the y is going to go away. It still happens because of the way the rules of natural log works. Let's look at fy, or partial with respect to y. So you guys, the first part's going to be exactly the same. I'm taking the natural log of x squared plus 2y. The derivative is 1 over x squared plus 2y. The chain rule is going to be different though. You guys, with respect to y, the derivative of this, well, the x squared is going to go away because it doesn't have a y in it. All I'm going to be left with is a 2. So with respect to y, I'm looking at 2 over x squared plus 2y. So similar, but not the same. Let's do this one. I'm going to combine just all kinds of terms because I can. So let's do 7x squared y to the 4th minus 3xy squared plus 5e to the x squared y minus natural log of y plus 2 plus natural log of x squared y squared. So this one's going to be very special. All right, so let's find fx. All right, so with respect to x, treating y as if it's just a constant, I'm going to take the derivative of x squared, but then the 7 and the y to the 4th are going to come along as coefficients. So I'll go ahead and write those down. Then the derivative of x squared is 2x. Minus y is a constant, so 3y squared is what comes down as the coefficients of x. let's talk about this exponential term. You guys, the 5 comes along, right? Because it's a coefficient. Also, what comes along? E to the x squared y, as is, because that's the rules of exponentials. But then I have the chain rule. You guys, I have to multiply by the derivative of x squared y with respect to x. So you guys, if y is just a constant here, it's just a coefficient on x squared. So it's going to come along. Then I take the derivative of x squared. And I'll make that look better on the next line. Let's talk about the natural log of y plus 2. You guys, is there an x in this term? I don't see an x in this term. And if y is being treated as a constant value, this whole term is a constant value. Don't let, just like with the e, I said don't trick yourself into thinking e is a variable. Same with natural log. Natural log is not a variable. The natural log is always the same thing, or it's just representing an operation, right? So the natural log of y plus 2, if y is just a constant, you know, let's say y is 5. Constant number. Notice you're just taking the natural log of a constant number, which is a constant number. That does not change. So because there's no x's in here, that whole term goes away. Now let's check out this one. This one does have x's in it, so I do the rule of natural logs. You guys, I have natural log x squared y squared. That's going to become 1 over x squared y squared. And then I'm going to multiply with the chain rule, right? So what's the derivative of x squared y squared with respect to x? Well, the y squared is a coefficient, so it comes along, and then I'll have the derivative of x squared, which is the 2x. So let's clean this up. You guys, let's call this 14xy to the 4th minus 3y squared plus, let's put 10xy e to the x squared y plus, let's see, let's call this 2xy squared over x squared y squared. Now, you guys, once you put that on top there, you can see that some things are going to cancel out. So I would go ahead and do that. You guys, what can cancel here? Well, both of the y squareds. And then you can take away some of these x's also. So you end up with just 2 over x. So that was fun, but we're only halfway done with that problem because we got to take it with respect to y now. So partial with respect to y equals. All right, back to the beginning. 7x squared y to the 4th. If y is our variable, then 7x squared is a coefficient. The derivative of y to the 4th is 4y cubed. Next term, 3x is a coefficient. Derivative of y squared is 2y. Next term, you guys, the whole 5e to the x squared y is going to come down. When I do the chain rule, you guys, x squared is just a coefficient on y to the 1st. So the derivative of x squared y is just x squared. I get to take care of this natural log now because I'm going with respect to y and it happens to have a y in it. So you guys, I get minus 1 over y plus 2. And you guys, on the chain rule here, the derivative of y plus 2 is just 1. So I'm just going to leave it like that. Now let's check out our last natural log. So the natural log of x squared y squared, take the derivative, you get 1 over x squared y squared. Your chain rule is going to be a different value here though, isn't it? If you're going with respect to y, then the x squared is a coefficient, and then you take the derivative of the y squared. So let's clean this up. We're going to get 28x squared y cubed minus 6xy plus, let's call this 5x squared e to the x squared y minus 1 over y plus 2 plus x let's call this 2x squared y over x squared y squared. And on this one, you can see some things canceling out. Let me make this a little more clear. That was a plus. So let's see, this time the x squareds go away. And you can take one of the y's away, and you end up with just 2 over y on that one. So I know this is a lot, you guys, this is fun. Practice is the best key here. You'll get to this point where you're not thinking about, oh, do I need a dy dx? Or you're not thinking, it won't be hard to see either x or y as just a constant value. It just takes practice. It's a new thing. You guys, I want to do one more. So on this one, I want to look at one where you could possibly require a power rule or product rule. How about that? So I'm going to give you e to the 5x times the natural log of y squared plus 3x. So why is this possibly going to be a product rule? Well, because I've got an e term and I've got a natural log and they're multiplied together. But it actually depends on which respect I'm taking. So let's start with respect to x. Now, with respect to x, notice this term is a function in x, and this term also is a function with x in it. So because they both have the variable in them that I'm taking with respect to, I know that I have to do the product rule. So let's take it to the side. That's what we do. We find u's and v's, right? Then we find, well, that would be weird. We find du's and dv's. All right, so let's say that u is e to the 5x. Well, with respect to x, du is just 5e to the 5x. Let's say v is the natural log of y squared plus 3x. Well, let's see, the derivative of that would be 1 over y squared plus 3x. And then the chain rule, this is just with respect to x, you guys, so the y squared is just a constant. The only derivative there is 3. So we could call this 3 over y squared plus 3x. All right, so let's put it all together. You guys, we have u times the derivative of v, so 3 over y squared plus 3x, plus v, which is natural log y squared plus 3x, times the derivative of u, which is 5e to the 5x. So there's not a lot of simplification here that you could do. Well, you could do a lot of things, but nothing that's going to make it look a lot better. One thing I would do is recognize this e to the 5x is on top of a fraction. You could put these two together. You could write it as 3e to the 5x over y squared plus 3x. Then just to make it look a little cleaner, you could put your e term in front here and get 5e to the 5x natural log y squared plus 3x. But you guys, there's not a lot else you can do here. So I would just leave it like that. Okay, so that was fun. You guys, let's look at with respect to y. You're going to like it a lot better. And usually when I say that, it means it's harder, but in this case, it's not. This time it really is easier. If I take this with respect to y, this whole term is a constant, right? Because there's no y's in it. So guys, I get to just treat that e to the 5x as a coefficient on the natural log. That means there's no product rule here. This is just a constant times a natural log function. So, like I said, a lot easier. You guys, so being a constant number, being a coefficient of this natural log, that term just comes down as a coefficient. Then I can take, using my natural log rules, and get 1 over y squared plus 3x, Be careful here, remember, because we just did this with respect to x. Don't think it's going to be the same, because this time I used the chain rule with respect to y, and my derivative here ends up being 2y. But that was a lot simpler, right? You can put the e term on top, you can put the 2y on top, you can call this 2y e to the 5x over y squared plus 3x. And that's it. So you guys, with respect to y, was a lot easier on this one. I'll be putting the homework up for this. I don't think I'll have time to do it before my next class starts, but it'll be after that. So just look for it this afternoon. This homework is not going to be due on Sunday night because I'm just teaching it now. That's too quick of a turnaround. You already have homework that are due Sunday night. So I'm going to put this on next week's homework, but it'll be up. Definitely you'll want to practice this. We are moving on to the next section on Monday, and we will heavily rely on partial derivatives in the next two sections. So in our last two sections, you need to be good at this. So while this homework is not due till next Sunday night, I would encourage maybe at least practicing it some. If you're, if you still, if you have trouble getting a grasp on it, or if this is all just very confusing, I would encourage practicing it before Monday. If you have time. I know you have your other homework to deal with. But other than that, guys, that's all I've got. And, if you have questions over the weekend, homework stuff, you know where to find me. If not, I will just see you on Monday.